Hello, my name is Markus Borg. I'm an adjunct lecturer with the Department of Computer Science, Lund University, Sweden. This is a paper presentation, and the paper is Making Programming Lab Sessions Mandatory on Student Work Distribution in a Gamified Project course on Market-Driven Software Engineering. A few words about myself first. My primary employer is RISE, Research Institutes of Sweden, where I'm a senior researcher. It's a state-owned research institute with a mission from the government to support tech transfer and make sure we can bridge academic research and industry needs. And I am also an adjunct lecturer with Lund University. We don't have any students at RISE, but I really enjoy teaching, so that's why I do that with Lund University. I teach one course per year. It's not a lot, but when I do it, I feel motivated and I try to do it very well. I'm also a board member of Swedsoft, a Swedish non-profit trade organization. And my background before I started doing research is in process automation. I worked with ABB on safety critical compiler and editor development prior to doing my PhD. I also do professional training, and at the moment I do it in collaboration with a company in Sweden called Axon. And at the moment there is a great demand for AI tutorials, so we have specialized in providing hands-on tutorials for not so tech-savvy audiences, especially for executives, leaders in various industries. This is the agenda for this recording. I first want to remind you that the overall goal of this work was to make lab sessions mandatory to help students. This is what we refer to as the intervention. I will first present the course, and then I will present an evaluation of this intervention. And I will do that by actually embedding a video from an ICSI poster presentation I prepared earlier this year. And it fits very well in this talk as well. So first, a presentation of the course. So the high-level goal here was to create a course with project-based learning in groups of 6 students, where students do end-to-end development of a software product. So this involves market analysis, requirements solicitation, design, implementation, testing, a few releases, time reporting, and then also price setting on the internal market. Some example deliverables that we work with in the course is a business model canvas, or a simplified version called a lean canvas, a sales pitch. There is a requirement specification, review protocols, test specification, test reports, and the source code, of course. And then the students obtain various practical skills throughout the course. They know Java when they come to my course, so we program in Java. There is some Eclipse development, continuous integration. We use Travis at the moment, JUnit, Git. They get used to GitHub, static analysis, and other things as well. In the course, we use Robocode as the underlying platform, and it looks like this: small autonomous bots. They battle each other on the screen. And so each group develops a Robocode bot for an internal tournament, referred to as a rumble within Robocode. And this is nothing new. This has been used in programming courses before and in software engineering courses as well. But we have a twist here in this course, and that is that no group here fields their own bot at the rumble. So instead, each group sells their bot to others, and each group then buys bots from other groups to compose a 5-bot team. So this is what we do to really introduce the market-driven aspect of software engineering here. You need to create a product that someone else wants, and then you have also a very healthy stakeholder relationship. Someone wants to buy a good product from you to win the battle in the end, and this is a great enabler for interaction between groups. So the Robocode tagline is "Build the best, destroy the rest," and it is a programming game. This is a concept. You learn to program by programming AI in a game, basically. Initiated in 2001, it was temporarily owned by IBM. It has been open source since 2005. It is actively maintained now by Dane Fleming Larsen. I've been in touch with him quite a bit the last years. He's very friendly and supportive. It is easy to get started with Robocode, but it can be quite addictive. There are some potential downsides with that as well for a teacher. There is really no upper limit in how advanced you can make your bots and your teams. We have seen reinforcement learning being used very successfully. Adaptive behaviors you can implement. Genetic programming has been evaluated in Robocode. Swarming, and yeah, you can do many things within this limited platform. So what I think is really cool when you do Robocode development in a project-based course is you force groups to really make decisions here, as illustrated by this train, choosing whether it should go left or right. So it's not only the technical decisions that are interesting here, you also need to do business decisions, and the interplay between business and technology is very interesting when teaching software engineering. We have 3 components in the course that all are gamified. So we refer to this as the engineering part, where students try to develop the best possible bot. And then we have the monetizing part, where students try to sell and make as much profit as possible. And then we have the strategizing part, where you buy bots from other groups to build a successful team for the Rumble in the end. So all these 3 things are gamified with leaderboards, and it seems to motivate students quite well. I'd like to show an overall picture of the project context here. There is quite some information here, but you can actually pause the video and have a look. I'll explain it just briefly. So each team is a rectangle like this. We have roles for the 6 students in each team. So all students are developers and testers. All of them are that. And then they have another role as well. So we have a project manager, software architect, a requirements engineer, a quality engineer, a configuration manager, and a sales engineer here in this setup. And then the sales engineer in each group will interact with a project manager in another group, and the project manager in each group will then of course also interact with a sales engineer on the other side in another group. And then we have the course assistants, the TAs, and the course coordinator here as the regulatory body, taking care of conflicts and things that might arise as we go along. And we also regulate the internal robot market, because you will realize that it's not easy to maintain a healthy market when students start trying all those different tricks and bending the rules. So you want to incentivize various actions on the market. And then finally, just wanted to show that we do the development in 3 sprints. Again, you can pause the video if you want to read the details here. We have a first sprint, and then we establish customer-supplier relationships, and we have a first alpha release. We have a second sprint where the product evolves, and a beta release, and then a final release after the final sprint, where we also continue with some acceptance testing and also business claims if the buying group was not satisfied. And then we have the rumble in the end, and we have some awards there and an awards ceremony and the like. So everything was quite different this year, 2020, because everything had to be done remotely due to the pandemic. But that's a discussion for another paper, I suppose. Time to evaluate the intervention.
Hi, my name is Markus Borg. I am an adjunct lecturer at the Department of Computer Science, Lund University, Sweden. I teach an introductory software engineering course where students in groups of 6 work together to develop a simple software product. And you know what? I have a challenge here. The student cohort consists of 2 different subgroups. So half of the students are first year ICT engineering students, and some of them just started programming a few months before. And the rest of them are third year students studying an engineering management program with a software touch. And they are more mature students, and they have also programmed more. The difference in programming skills has been a problem in this course over the years. Some students really struggle, and other students, they compensate by working too much. So to bring the weaker students to a higher minimum level of programming in this course, we turned 4 computer exercises into mandatory lab sessions. And thanks to identical measurements before and after this intervention, we could evaluate the effects. So what happened?
This is the poster, and I will now guide you through the key results. Looking first at the total hours reported by the student groups. In blue here we see the 2018 results, and 2019 is in orange here. This is after the intervention. And what we can see here is that there is no practical difference between before and after the intervention. We continue by looking at the total time reported per role on average within the student groups. And on the left hand side here we see the roles used in 2018 before the intervention. It's not super important what they are. And on the right hand side we see the roles used in 2019 after the intervention. And there are some differences here, but they are almost the same. And what we see here in the box plots is the distribution of time spent by the different roles, and we see no obvious differences here between before and after the intervention. We see that the DL here, the development lead in 2018, and the test lead, they worked many hours, and we see the same tendencies here with the quality engineer in 2019 and the software architect in 2019. Now we take a look at some qualitative analysis. We had an exam question in 2018 and 2019 where we asked the students to provide a retrospective of the group work, and this is the result of this analysis here. Looking at the individual work balance, we see that after the intervention we found more of deadline crunching and an increased need for planning. And looking at the work balance within groups, we see that the students found the programming now to be less laborious than before the intervention, but we also found that the students found it harder to delegate the work. Finally, we look into what the formal course evaluations indicate, and the results are here. So we have here for 2018 results, the total results, all students, and then the ICT students and the management students, and in 2019 the same structure. And what we see here in the results is that the ICT students were less satisfied with the course after the intervention, but the management students were more satisfied after the intervention. Okay, time to summarize.
What did we learn here? What did the intervention result in? First, students did not balance their individual workload better. The crunching towards the end of the project instead increased. Second, the variance in total effort within the student teams did not decrease. The students responsible for the source code failed to delegate. Third, we designed the intervention to help novice programmers, but they didn't appreciate it. Instead, the mature students were positive. Please have a look at the extended preprint and reach out if you have any questions. Thank you for listening.
Thank you so much for listening. If you want to know more, all details are available in the preprint available on Archive. And the course material, everything is available under a Creative Commons license on GitHub, and everything is in English. If you want to ask me questions directly, you have my contact information here. Thank you very much. See you around.